In this lesson, I will introduce two-way contingency tables in probability. Contingency tables. Contingency tables are statistical tables that represent the relationship between two or more variables. Contingency tables are especially useful when surveying the attitudes of people in a community towards something that has happened or is planned for the community. We show the frequencies of each variable in rows and columns. Example 1. A group of elderly people were asked if they utilized the disabled parking bays at the shopping mall. Of the 400 respondents, 35 were disabled and 365 were not disabled. The results of the questioning are tabled below in the contingency table. So let me just quickly explain to you what is happening here. So in the first row you find disabled, not disabled and total. And then use disabled parking bays, this 12. And then not disabled using disabled parking bays is 305, and when you add these two you get 317, and you also add down. So if you add 12 and 23 you get 35. So all the numbers 305 plus 60 is 365, and then as well 317 plus 83 is 400, and 35 plus 365 is 400. Can you see your table is balanced? Let's look at the questions. Calculate the probability that a person drawn at random from the sample space is disabled. So what you do is you go to the person that will be disabled. The total there is 35 out of the 400, 0.09. Number 2, calculate the probability that a person drawn at random from the sample is a disabled person who uses the parking bays. So a disabled person who uses a parking bay is going to be this 12 out of 400, which is 0.03. Number 3, calculate the probability that a person drawn at random from the sample is not disabled and does not use the disabled parking bays. So where is it now? Is not disabled and does not use, I think it's going to be the 60 out of 400 is 0.15. A group of 10,000 people were tested for color blindness, and the results are shown in the table. So in the first row there's male, female, total, and then in the first column there's colorblind, normal and total. Number 1. If a person is chosen at random, what is the probability that the person is a colorblind male? So you go on your table to male and colorblind. Where they meet is there, and therefore the probability male and colorblind is 393 out of 10,000, which is 0.0393. Number 2, does the evidence support the statement that color blindness is independent of gender? Now, independent of gender, can you remember in lesson 1 we had this product rule for independent events, which stated probability P, A and B is equal to probability A times probability B. And we actually worked this one out already. Probability A and B, there it is, probability A and B. So now we're going to work out probability PA times PB, which means probability male times probability colorblind. And if the two are equal, then yes, that they are independent. So probability male is 4,910, and then the probability colorblind is 408 over 10,000, and when you calculate that you get 0,02. So can you see on this side, the left hand side, this one is 0,0393 and these two is 0,02. So therefore they are not equal, therefore they are not independent. In the next lesson, I will discuss more practice examples on two-way contingency tables. Click on the video in the left-hand corner to take you straight to the next lesson.